Hi guys, second recording of the video of a video today. Um, Apologize. I know I said I was going to have it up by noon or so, but I got distracted with the historical event of today or yesterday, depending on when you're watching this. But uh, I just got done watching the inauguration of our new president, and it's something that is historic and always happens every 4 years. So it's not something we see all the time. So it's always good to be a good citizen and be a part of that. And the message was really great. How to come together as a United States of America, and that's a really powerful message that we all need to hear because we're only as strong as we are together. So, with that said, let's get rolling into math. Lesson 11, we are subtracting our fractions. So we're going to have to create common units again and maybe regroup by renaming some of our wholes into our fractions to make them a fraction greater than a whole, basically, so that we can subtract with. So let's go ahead and start. Let me minimize myself, move myself out of the way, and give myself some space. Oh no, I just realized I'm not talking on my mic. So let's plug it in. Okay, hopefully the quality just got a whole lot better. And I apologize for not realizing I didn't have it plugged in. So let's get rolling, let's get started, and let's get subtracting some fractions. So let me give myself some background, and let's start with 1/3 minus 1/5. Now remember, we always have to have common units to be able to add and subtract. We can't add apples to apples or oranges. Sorry, we can add apples to apples, but we can't add or subtract apples and oranges, right? So they have to be the same unit. And right now we know that they're not the same unit. We have thirds and we have fifths. And this is where we were talking about in the last week or so, counting by your units, multiples of your units. So I'm going to count by fives, 5, 10, 15, 20. And then I'm also going to show counting by my 3/3, 3, 6, 9, 12, 15, 18. And we can see where there's a common unit. We can see that we can make them both 15ths. So let's go ahead and do that conversion down here. We're going to show 1/3 is equal to something 15ths and then we also can show 1/5 is also equal to something 15ths because we know that we've identified which one of these is the common unit. Now, I like to do it that way because then I just think, what did I multiply 5 by to get to 15? And you can also see it over here in our multiples, 1 multiple, 2 multiples, 3 multiples. So really, we did multiply by 3. So we're going to do that same to the top because we're not just cutting the whole, we're also cutting the parts into smaller pieces to make 15th. So 1 times 3 is 3. And then over here on our other side, what did we do to get thirds to 15ths? Well, we multiplied by 5, and we can prove that over here on our counting by our multiples of 3/3. 1, 2, 3, 4, 5. It was 5 groups. 1 times 5 is 5/15ths. So now we just rewrite our sentence. So I'm going to come back to the top. I'm going to say it's equal to 1/3 minus 1/5 is equal to, well, we're going to make it, is my stylus messing up? We're going to say that it's equal to 5/15ths minus 3/15ths. And that really equals, well, what's 5 minus 3? Well, it's always 2, right? So 5/15ths minus 3/15ths is going to give us 2/15ths. So when we can, we always are going to have to create common units. And on this situation, we could subtract without regrouping, but there is going to be situations where we're going to have to rename our units and then figure out if we have to regroup any of these. So let's go ahead and try another one. Let's go ahead and try 3/5 minus 1/6. Okay, so the first thing we always do, notice the fraction, notice the units, and we're saying to ourselves, fifths and sixths. Are they the same? No, they're not the same. So we have to create a common unit. What can we count? oh man, bell rang and I can't speak. What's the common unit? Well, if we count by 6 sixes, 6, 12, 18, 24, 30. I'm going to stop there because I know 30 is definitely one. Let me also try counting by my 5/5, 5, 10, 15, 20, 25, 30. Okay. So we know 30th is going to be the common unit. So let's just show our conversion. 3/5 is equal to something 30th. We know that that's the common unit. 1/6 is also going to equal something to 30th. But now let's think about that. Now we can use our counting by our multiples to figure out what we multiplied by. Or we can think, what did we multiply by the bottom from 6 to get to 30th? Well, that was a times 5, right? Whatever we do to the bottom, we want to do to the top. So 1 times 5 is 5, right? And over here, what did we do to get 5ths to 30th? Well, we multiplied by 6. So if we do that same thing to the top, we get 18 30ths. So let's rewrite our sentence. 3/5 was the first subtraction fact. So we're going to do 18 30ths. We want to keep it in the same order. Seems like at the top of my computer screen does not like my stylus as much as the bottom. Seems to glitch out. Come on. Oh, that is just. I think maybe I figured what is going on here. Look at that. That is really frustrating. Let me pause my video and see if I can fix it. All right, I don't really know what's going on, so bear with me. I'm gonna use my finger at the top of my screen. So it's 18 30ths minus 5 30ths. So now if you need to stack 18 minus 5 over on the side, you can, so that you can work with that. Whoops, sorry. Or if you can do that in your head, also great. Well, 18 minus 5 is what? Well, 18 30ths minus 5 30ths is going to give us that same answer, but we got to keep the unit the same, 13 30ths. Great job. All right, so let's try one where we actually have to regroup to solve. Right now, we have always been able to subtract the smaller piece from the larger piece, but what happens when we have to regroup from our wholes to get that? Let's go ahead and practice one of those before we move on to our problem set. Let me make sure I find a good one. Oh, are none of them going to regroup today? I don't think any are going to regroup today, maybe. So let's go ahead and just try this one. Oh, I don't know what's going on. Let me write this on the bottom of my screen. Look at that. Works perfect. Same stylus. Works great down here, but not at the top. Strange. 3 3/5 minus 2 1/2. Okay, so right now, there's a couple ways we can do this. We can kind of take the wholes separate from the fractions, or we can kind of do them. There's multiple ways. There's like 3 different methods I can think of to solve. We can subtract the wholes and then deal with the fraction, or we can kind of do them all together. Let's break it apart by our wholes. Right now, can we take 3 minus 2? Yeah, we can do 3 minus 2. And what happens is that creates 1. Now what we're going to do is we're going to take the fractions and keep it together. So we're going to keep this 3/5 with this first whole number, and we're going to subtract the next part of our this number. Oh my gosh, my stylus doesn't work on the top part of my screen. That's really frustrating me today. So we're going to now show 1 3/5 minus 1/2 because we've already shown 2 taking away from 3. And that's our 1. And nothing else has changed, 3/5 minus 1/2. Now this is where we want to think, okay, can we create common units? Let's count by our 5/5, 5, 10, 15, 20. And let's think about counting by our 2 halves. So 2, 4, 6, 8, 10. I see a common unit in the tens. So I know that we're creating tenths. Okay, so what we want to do is just convert the 3/5 because we know 1 whole is going to be 10 tenths when we convert that. So 3/5 is equal to something tenths. Well, what did we do to the bottom? Well, we multiplied it by 2 to get to tenths. So our top is going to be 6/10. Now 1/2 going to tenths, some of us can see it instantly because we know it's just going to be half of 10, but what did we do? Let's prove it mathematically. Well, we multiplied by 5, so the top 1 times 5 is going to be 5. Now let's rewrite the sentence. We can't forget about the one whole number that we're working with. So it's 1 and 6/10 minus 5/10. And we can see, well, we can take 5/10 away from 6/10, so nothing changed to the one whole, and all we're left with is 1/10. Now, if you found a different way that you think you could solve for that, go ahead and try it. Some of us would convert all of the fraction into an improper fraction to try it. And I'll show you one of those examples on our problem set. So let's go ahead and move on to our problem set. Let's zoom in. And fit to width, yep. And so let's take a look at the page. We got generate equivalent fractions to get like units and subtract. Great. Let's see what the second page is. All right, we're only doing the front page. We're only going to ask you to practice these ones. Okay, so you don't have to do any others. But let's jump right to the bottom because I want to talk about that one example that I was talking about where let's cross that out too, where we're going to show creating it into a different method than subtracting. So I want to do this G in 2 different methods. I want to do it in the method that we just practiced. So let's do that. Let's rewrite this sentence after we subtract 5 minus 2. What's 5 minus 2? Well, that gives us 3. So it's going to be 3 6/7 minus, well, we've already subtracted the 2, so it's just minus 2/3. Now that we have that, oh my gosh, my stylus is really frustrating me today, guys. I'm sorry. Now that we have created or simplified the sentence to just show a mixed number minus a part, now we can create common units. So if I think about this, 7, 14, 21, 21/21 is going to be the unit. So 6/7 is going to equal something 21st, and 2/3 is going to equal something 21st. Well, what do we do to thirds to get to 21? Well, we multiplied by 7, so our top is going to be 14. Well, what do we do to the bottom to get to 21? Well, that's a multiply by 3. Again, here's where I say knowing your multiplication factors is really important. And then 6 times 3 is 18. Now, let's rewrite it with our new common units. So 3 6/7 is really 3 18/21 minus 14/21, which is going to equal, well, can we take away the 14/21 from the 18/21? Yeah, 14 is smaller than 18, so we definitely can do that. Our wholes, we've already dealt with them, so we just bring that 3 over, and we're left with 4/21. Now let me change my color here. And I'm going to do a different way on the right-hand side. And in this way, we convert everything to a mixed or improper fraction. So let's see what come on, stylus. 5 6/7 minus 2 2/3. So what we want to do is we want to convert this into an improper fraction. So we know that 1 whole in 7ths is 7/7. So if we counted 7/7 5 times, we should get 35/7. There's 5 wholes. Now, we got to add that back to our 6/7 because this is one big number. We got our wholes plus our part. So 35/7 shows our whole plus 6/7 will equal 41/7. Okay, let's keep that in mind. Let me change my color so we don't get confused. Now, on this one, our unit's thirds. So how many thirds is 2 wholes? Well, let's count 3/3 twice. 3/3, 6/3. Well, 6/3 plus 2/3 is going to give us 8/3. So now we can rewrite that. Now we can show 41/7 minus 8/3. Well, we still have to create common units. Now, this is why this method, I feel, can get a little clunky. Because let's think about it. We said we want 41/7 to become 21s. Well, what's 41 times 3? Because we know 7 times 3 to get to 21. What's 41 times 3? Well, do you know that? Well, it's not as easy as just doing it in your head, right? As a simple basic math fact. So 41 times 3 should give us 123. And I messed that up over here, so let's just rewrite it. 123 21st. Now, 8/3. We want that to equal 21st as well. Well, 3 times 7 was 21. 8 times 7 is going to give us 56. So really, let me change back to yellow. I know it gets, when we do all this work, it sometimes gets a little hard. 123 21st minus 56 21st. So now again, do you know what 123 minus 56 is at the top of your head? No, but you could stack it and subtract. Now I'm not going to do it because I feel like this method, as you can see, creates a lot more clunks than this method. So you, as long as you get to the right answer, we're proud of you, but make sure that you're practicing that. I'm going to pause. I hope you pause. I want you to go ahead and try your best independently on the rest of this. And when you unpause, I'll have all the work showing. All right. Before I scroll down to the next one, I just wanted to show you this. You can see that my common units are 6, and you can see how I've multiplied those to create common units. And then you can see I rewrote the sentence up above to show my answer. Same thing over here, showing my common unit work down below, and then showing my rewritten sentence up above. All right, pause me again. Or if you did all your work, you can just keep me playing, and I'll magically have the new work or new answers here in a second. All right, I'm back, and you can see the next two problems. Eighths were the common unit over here on C. We didn't have to do anything to eighths to convert it because how do you get from 8 to 8? Well, you multiply by 1, so nothing's changing, right? Multiply by 2 on the other one, get 7/8 minus 6/8. Over here, this is one of the things that I think we gotta be careful. I showed my conversion of the fractional units, but notice I didn't just put 16/40ths as my first number. It was 1 and 16/40ths because we didn't need to convert the one whole on this problem. All right, pause me again and we'll go ahead and do the last two. All right, let's check my new work. You can see my conversion for E, the common unit is 30ths. Both of them get to 30ths. And once again, this is 1 and 3/10. So I've only converted the fractional part down here, but when I rewrote the sentence, 1 and 9/30ths. Okay, so make sure that we're remembering that when we're doing this conversion style. Over here on F, you can see the common unit is 15ths. And then I can rewrite it as 2 and 5/15ths minus 3/15ths, which gives us 2 and 2/15ths. All right, so nice job. Get a chance to do this at some point this week. We have NWEA this week and Monday of next week because we didn't have Monday this week. And then we will keep on moving on. So nice job today, guys. I'm about to start in 20 minutes our Zoom lesson for Pictionary. So I'm hoping that I'll see a bunch of you there. All right, guys. Have a good day.